In chapters 2 and 3, we were pretty much always working with a single variable. We would have frequencies sometimes for that variable, like in section 3.3, where we'd have frequency or relative frequency. However, the variable itself was really only one variable. Now in chapter 4, this is kind of the one chapter where we're going to break that, and we're actually going to look at two separate variables that have a relationship. Maybe. They might have a relationship. We generally work with them when they do, but they might not as well. Now, those two variables, we often use the letters x and y to represent them. Now, that should sound familiar to anybody who's ever taken an algebra class, but they're not quite the same as the x and y that you learn in algebra. In algebra, you learn the x is independent and the y is dependent upon the x. And you can learn a very specific relationship like y equals 3x plus 2 or y equals mx plus b to explain that relationship. And it's very lockstep. But in statistics, it's more wishy-washy than that. So we call x the explanatory variable. So it's like the independent, right? It's the one that we kind of first look at and we say, hey, this is something we can manipulate. We can manipulate this x. Does the response variable y respond to that manipulation? So it's not as in sync as algebra is, right? When you were working with parabolas or lines or something like an algebra class, it's more wishy-washy than that. It's more, hey, the x changes, maybe the y changes, maybe it doesn't. Who knows? Let's discover this relationship, right? And that's what we're working with. So it's a little bit more fuzzy. Okay, now one of the first things we have to do to kind of analyze that fuzzy relationship is to be able to graph it. We want to be able to see a picture of what's going on. And that is what a scatter diagram or a scatter plot will do for us. It's a graphic tool that's used to display the relationship between two quantitative variables. All right, so let's look at what a scatter plot looks like, and then I think you'll get it. So the following scatter plot shows the relationship between the number of children per woman. Oh, sorry, that's the number of births per woman. That's a typo. Births per woman in a country, and that country's average life expectancy in 1962. The table shows a few of the countries in the data set. Okay, so I'm not giving you every one of these data points. So I'm giving you a few of the countries, and then see the dot dot dots. That means that there's lots more in there because there's like 190 countries. And then there's the US's value in case you're interested. I've got it highlighted because we need it highlighted later. And then there's Zimbabwe where we end. So this is what a scatter diagram looks like. And every one of these dots represents a different country for that time or for that year. So in 1962 there was some country that was, this is about 5.03 and 59.28. And there was another country that was something else, right? 3.98 and 70.57. So every country is its own dot, right? And there's an X and a Y for each of these countries. So the X being the fertility rate, right, these numbers right here. So you go over whatever that X value is, and then you go up whatever this Y value is, and you put a dot for each of the countries. And ta-da, there you have it. Now, just in case you're curious, this dot right here is kind of part of that blob. There were a few countries actually. There's a few dots there at the same time, but this one right here is the US's numbers of 3.48 and 70.21. So if you kind of pick out that little part of that blob, there you go. And I could do that for all the countries, but I'm not going to because then, well, it'd be all rainbow colored and we wouldn't be able to see anything. Okay, so the first question is, what is the explanatory variable and what is the response variable? Well, in general, the explanatory variable is going to be your x, which is going to be on your x-axis, and your response variable is going to be your y. So explanatory for us is fertility rate, and the response variable is the life expectancy. Now, they didn't specifically ask for it, but it doesn't hurt to note that there are units for both of these. And the units for fertility rate is births per woman. The units for response variable is years. All right, so now let's look at the US's values. The US was 3.48 and 70.21. So let me write that up. Now, what does that mean? Well, that means that in 1962, women were having about 3.48 births per, well, births in their lifetime. And then a baby born in that year in the US was expected to live to about 70.21 years. Now, in 1962, the African country of Rwanda had a birth rate of 8.2 births per woman and a life expectancy of 40.374, or excuse me, 43.74 years. In I don't know why I said in 1962 again. Sorry about that. All right, circle and label Rwanda on the graph. All right, so if I go back up here, Rwanda I chose on purpose because Rwanda was the farthest over in the number of births per woman. So at its value of, what is it, 8.2, that's right here, 8.2, and then a birth rate in, or excuse me, a life expectancy rate in the 40s. So there we have it. Oh, and I lost my dot. My computer freaked out on me, so let me put this color back in here for the US. There we have it. Okay, so now let's think about some things like fertility rate and what it means in terms of what type of variable that is. So the fertility rate is the X values here, and you can see them right here. So it's the births per woman. And births per woman is an overall average for a country. We all know that a woman can't have 3.48 kids. So if you were wondering about that earlier, it's not really about any one woman though. It's about, on average, that's how many we expect for all the women in the US in 1962. Right? And if you think that people don't track that, oh, you'd be surprised, right? So hospitals want to know that kind of thing. School districts want to know that kind of thing. So if they know how many women live in their area, then they know how many children to expect in their area, that kind of thing. So what type of variable is this? Well, it's quantitative continuous, right? Because there are decimal places here, and different organizations might measure it with more accuracy. So you might have more decimal places depending on what country you're in. So that's quantitative continuous, not because you can have a continuous amount of kids. That's not what I'm saying. I'm saying that that average that you're looking at could have more decimal places. We only went to 2 decimal places, but you could imagine it could have 3, it could have 4, because it's really an overall number for an entire country. By the same token, it also has to be ratio, because there's no way in heck a quantitative variable like this could be negative. You can't have negative amounts of fertility in your country, right? The lowest you could ever have, well, you can't have it, but it would be 0. Of course, nobody has that because that would mean your country is having no children whatsoever. So ratio is the numerical values that cannot go negative. So that would be ratio. Now, what kind of relationship do we see? Well, we see that countries that are over here on the right, they have a higher fertility rate and a generally lower life expectancy. And then over here on the left, we have countries that have a lower fertility rate and a higher life expectancy. So we're seeing a negative relationship. We're seeing that as the life expectancy decreases as the fertility grows. So I just typed that up here. If a country has a larger fertility rate, so farther over onto the right of the graph, then it'll generally have a lower life expectancy. So it'll be lower. So there's groups that are to the right and low, and then there's groups to the left and high, right? So in other words, let me put it this way, smaller X values correspond to higher Y values as well. Let me just say also. This is called a negative relationship, right? So a negative or inverse relationship. So between the two variables. So when one goes up, when X goes up, Y goes down, and vice versa. So that's called a negative or inverse relationship. Okay, now that leads to me, why did I choose 1962? Because you might have been wondering about that. Like, what was my reasoning? And my reasoning was that 1962 was the year that the terms first world, as in there are first world countries and there are third world countries, were coined by the U.S. ambassador to the United Nations, in fact. And you can see it a little bit in the graph. There's a clump over here on the right, which are the third world, quote unquote, countries. And then over on the left, there's the first world, quote unquote, countries. And what did that mean? Well, that meant in the first world, over here on the top left, high left corner, that meant that they had long lives, right? They were living longer and they had smaller families. And then over on the third world side, where Rwanda is, amongst others, it had short lives and larger families. Now you might be thinking to yourself, what about the second world? What was that? Well, it was 1962. So the second world was considered to be the Soviet Union and all of its friendly neighborhood countries, so Poland and Hungary and Czechoslovakia, Yugoslavia, that kind of thing. So those Eastern Bloc countries were the second world, quote unquote. So the first world was supposed to be the Europe, Australia. This is 1962. So Europe, Australia, the U.S., New Zealand, those kinds of countries, and probably Japan, Singapore, those ones. And then in the third world countries, because I don't mean to imply that it's only, non-Asian countries, because there are actually several Asian countries in that group as well. And then the third world countries would have been, for example, sub-Saharan Africa, Haiti in the Eastern Hemisphere, sub-Saharan African countries, so Zimbabwe, Rwanda. I can just pick some. Of course, Afghanistan is in the mix there too. Afghanistan has historically been a very poor country. All right. So one of the reasons that I bring this one up, this particular one, is that this was actually the child of Hans Rosling. So if you can look him up on YouTube, he has actually sadly since died of cancer, but he was a famous Swedish scholar. And he has actually a lot of TED Talks and YouTube videos, and he invented something, and now his legacy is living on through, I believe, his children and others. It's something called Gapminder. This is 1962. And you can see over here, see, there's Japan in the top left corner, just like I said it would be. There's the US and so on. You can see, oh, Canada. I forgot about that one. Canada should be in there. There it is. So you can see all these different countries. There's Argentina. That's in the top left corner. So there was a bunch of countries over there when this term was phrased, or excuse me, when this first world and third world was coined. And then you can see there's a mix. And you can see also this particular graph is a very powerful scatter plot that shows a lot. And we're going to go to this website for getting data for some of our projects. So it's a handy one to look at. Now the yellow countries, here they are, they're blinking at you. They are the Americas, so North and South and Central America, right? We're kind of all over the place. Then you've got the blue dots, which are your sub-Saharan Africa. You've got your green dots, which are the Middle East and North Africa. You've got the orange dots, which are Europe and Central Asia. And then you've got your red dots, of course, which are Asia and South Pacific. And then right there, South Asia. So that would be Afghanistan, India, and so on. Now the danger and the reason that this actually talk was given, and this graph was looked at in the State Department of the US, where we send our diplomats. That's what the State Department is. And so they looked at this over time, and everybody looked at it and said, well, of course, there's first world and third world and so on. But the danger is that it might not be exactly what you think it is anymore. So if you press play down here, you can go through time and see different years. So there's 1964, 1965, and so on. I'm just going to let it zoom through for just a second. And you can see countries are moving, right? Things are not quite what we thought they were. And a lot of people in the State Department were very surprised by Hans Rosling's talk about this. And again, you can actually go see the talks. It's on YouTube and on TED Talks for sure. He gave several of them. And you can see that the world today is not quite what we thought it was. A lot of the countries that people in the State Department said were third world, quote unquote, are right with us in terms of life expectancy, birth rate. Here's the US right here, but you can see Colombia is right next to us, Belgium. You've got Turkey, right near us, Uruguay and Bahrain and Sri Lanka and Vietnam, and of course the huge one, that big red dot there is China, because the larger the dot is, the larger the population. So this graph shows not only time, but it shows population. The color is showing the different world regions. And it's showing the X and the Y. It's like a scatter plot on steroids, right? It's super, super powerful. It's called a bubble chart or a bubble plot. So very, very powerful. There is still an issue with some third world countries, and you can see a lot of them are blue dots. Niger, Nigeria, Congo, Mali, these are sub-Saharan African countries. There's Timor, which is a very tiny island in the Pacific, stuff like that. The Solomon Islands, these are very poor islands. Palestine, Iraq, right, Yemen, etc. But in general, the world doesn't look quite like we thought it would when way back in 1962. And it's a dangerous thing to treat the world of 2018 as if it's the same as the world that it was in 1962. And that was Hans Rosling's point. And it's a good point to learn.